Hey folks! In this video, we're going to take a look at how to create and use a mutex with pthreads. The basic problem we're going to look at is having multiple threads running at the same time that want to add a node into a global linked list that everybody can see. That's going to be what we're going to try. We're going to try to build. We're going to try to build it without a mutex first to see what happens, and then we'll add a mutex afterwards, right? So that's going to be our demo situation. So let's maybe try to draw for a second how this thing will look, right? So I know that I'm going to have a linked list, right? So I want to have a linked list. I'm going to add things to it from different threads, right? So we already know, right? A linked list looks something like this, right? I have basically these boxes, right, where one knows about the other, right? So a simple linked list, right, might look something like this, right? My head variable knows where the beginning is, right? So we've done this before, okay? So how does the situation maybe change when we do threading? Well, let's suppose for a second that we have different threads running, right? So there is maybe, you know, some big global list. And actually, let me fill in here. Let me label this. Let's say this is node 1, node 2, node 3, right? So this is something that we could easily build what we've already seen with linked lists. But suppose we want to do something with threading. So how would it maybe look? And let's just kind of jump in the middle here and we'll try to visualize for a moment. So I have my program running. My program might already have a list kind of started. And basically maybe it's a list that has something like maybe just one node in there, right? So maybe there's something like this. There's a node 3 in there, right? So my program is, you know, running, right? And then there are two threads out there, right? There are two threads, right? So I have a T1 and a T2. And if I tried to draw a picture, right, maybe my picture of this would look something like this, right? I have, you know, P1 is this big thing running, and then there's another thread running, and then there's another thread running, right? So this is, you know, maybe my T1 and my T2, right? So maybe my picture looks like this, right? So all of a sudden I have three things running at the same time, right? And maybe my goal is basically T1 adds 1 to this list, T2 adds 2 to this list. And already you can know it's going to be a little bit weird just because like that ordering isn't guaranteed, right? I mean, I don't know which order they're going to run in, so I don't really know that my ordering of my nodes is going to be exactly what I have up top, but that's okay. Let's say that the only thing we're really looking for is to see that all three values are in there. So let's just make that assumption and it'll make at least this possible and reasonable. So what we want, right, is basically each thread to be able to construct a node, right? And that's not too tricky because we basically know, well, I put my wrong number there, but we basically know, right, that just requires a malloc. I create a node. I can kind of keep it to myself. It's not a big deal, right? So maybe, right, each of these have a variable called, for example, you know, node, and node is going to have, you know, basically a pointer to the node that they want to add to the global linked list, right? So I have something like this, right? So there's somehow 3 nodes out there in the world. Now the problem, right, is that depending on the order these go in, you may actually see a different result. So suppose for a second right here that we're running, right? And I know that in a linked list, right, basically what happens is that if I want to add a new node to a linked list, I basically take my node and point it at what's already there, and then I update my head, right, to look at the new thing, right? That's how I would add a new node. Now, if I think about this in terms of threads, right, and things happening in any order, my ultimate problem here is the following. I could have basically T1 decide that it wants to add. And that means it's going to have an arrow to this, right? So it updates next to be looking at 3. And then maybe T2 goes for a little bit. So now T2 has an arrow over here. So all of a sudden I have an arrow from 1 to 3 and 2 to 3, right? So like the individual linked lists within the threads, both of them are looking at that head variable. So I have a picture like this. It's not too broken yet, but then the problem is that basically at some point you're going to have to update the head variable, right? So the head needs to point to the new head of the list, right? So this has to go away for sure, right? And then, right, my head variable, it could be that it ends up pointing at 1, right? If this, well, okay, so it could end up pointing there, or it could end up pointing over here to 2, right? Because basically what happens is both of those threads think that they are connecting their one node, you know, either 1 or 2, depending on what thread you're in, to that one node 3 over there, right? And so it might be that, for example, T1 goes first, right? So if T1 completes first, well, then it'll basically update head to know about the new star of its list from its perspective. So it thinks that 1 is a new star and 3 is what's already there. So then all of a sudden, right, if T1 goes first, right, so let's say it goes first, right, let's say it's like active over here, right, then what happens is you have a list that looks like head is pointing at 1 and 1 is pointing at 3. But then, right, let's say then later on 2 goes, right, so 2 activates later on, it breaks this link here, and all of a sudden head is instead a pointer to 2. Right? And so in that case, right, where T1 goes first and T2 goes second, you actually get a picture that instead looks like this. 2 is a pointer to 3. head is a pointer to 2, right? And this is not our overall picture, right? Really what we want is this. We want to have all 3 in there. We already said that the order might differ. That's another thing. But for now, we just want all the nodes to be in there. And that is clearly not the case, okay? So this is our issue with basically handling this global linked list when we're using multiple threads. So this is the problem we kind of can expect to see. And so I think what we'll do is we'll try to first implement this in a single, in a single thread, or basically in the main process. We'll take a look at how that works, and then we'll expand it out to use threads. Hopefully we can actually see an issue running it. It's going to be a little bit tricky. It's hard actually to cause this to occur sometime, but we'll give it a go. And once we've done that, we'll go and actually add the mutex code to make it work properly. But initially, right, hopefully this makes a little bit of sense. Your goal here, right, with this drawing is basically to convince yourself that if I have a global linked list and I let threads run at any time, there's a situation where basically one will make another forget about the node that it just added, right? Because it kind of overrides it. So that's the takeaway here. All right, so now we've had our discussion here, let's go back to CLI and do some actual coding. So the first thing I'm going to do is create a new struct, right? So I have a linked list, right? So I know I'm going to need to have some basic things. I think I'm going to implement a struct, maybe some global variables, a function to add to the front of the list, and then maybe something else to display it. And it'll help a little bit with debugging later. So let's go ahead and start with that. So the first thing I'm going to do is I'm going to create a struct so that I can actually have nodes. So we'll just call it something simple. We'll call it data node. So data node, that'll be pretty simple. I'm just going to put one thing inside of here. I'm just going to put a piece of data, right? That's going to be our numbers that we're basically adding to this list, right? So like the 1, 2, 3 we had in our picture. It's a linked list, so I'll go ahead and add in a reference to next. Some of the linked list code I'll go through a little bit quickly, just because we've seen linked lists before, and I think by this time you probably have a bit of practice with them. So hopefully that is okay, and we'll spend our most time right on the logic that is kind of new to us here. Okay, so I have my struct represents a node. Let me put it in a global. So this is, well, I'm putting this in, but it's also the one thing that kind of causes this trouble, right? Is having a global variable that everybody wants to use. But in the end, right, if you want different sources to use the same data, they all have to have somewhere to go, right? We just need to make sure they use it safely is what it is at the end of the day. So let's go ahead and do that. I'm going to call it just list head. I'm going to call that, or I'm going to set the equal to null, right? So we're going to say that initially there's nothing there, okay? So I have my struct prepared. I have the start of the list. Okay, that's good. Let me add something to basically add to the list, right? So I'm going to do an add front. So I'm going to do the simplest type of add that I can. So we'll do add front. Add front. We'll do this style syntax or of variables. Okay, so I have my add front here. And I think what I'll do is I'll start by doing the memory allocation, right? So I'm going to need to create a new node, right? So basic idea is this is a function that I have a piece of data I want to add to the list. This will make a new node and attach it to what's already there. That's going to be the idea for this function. So struct, not node, struct data node. There we go. Struct data node. And I'll just basically malloc a new one, right? So this is obviously our dynamic data structure, so we'll need to do a malloc here. So malloc size of struct data node. All right, there we go. So that gives us enough memory. And it's pretty simple, right? Basically to set up the node itself, right? So I have a new node. I'm being told, put this data inside of it. So I just need to do that as an assignment, right? So node or data equal data. That's pretty straightforward. And then, right, if I think about this just in the traditional linked list sense, I need to attach it to what's already there. That's going to be a couple lines, right? So I have a node. So I want its next to be the things that are already there. So we'll do something like this, equal list head, right? That's the global list that's out there. So, I'm attaching the front. So I put the next to the stuff that's already there. And now my head becomes the new node that I've been using, right? So it's like this. And that's my simple adding to a front of a list, right? We've done this before. Hopefully this seems kind of at least a little bit familiar. Now I'm going to do a couple things here. I want to do a couple things. So to start with, we're going to try adding nodes just from the main program because I want to make sure that it compiles and runs and we know what's going on. So let's do a couple things. We'll start by basically just calling add front a little bit. So I think maybe what we'll do is we're going to have a loop over here. I just want to add a bunch of nodes, right? So I'm going to call this a whole bunch of times. So let's just do something like this. For int I equal 0, I less than 10, I plus plus, right? And if this is just kind of a normal program, then basically what I'm going to have in here is I'm just going to call add front, right? So we haven't done any threading yet, right? We'll get there, but let's just do the quick mock-up with a normal program. So if I run this, hopefully it compiles. Yeah, I won't display anything yet because it's just, just adding them right and not displaying anything. Actually, let's fix that. Let me add a quick display function because I just want to verify. Well, I want to verify a couple things. I want to verify what's in there, and then I want to verify how many nodes are in there, right? Because the thing is that we already said the contents in the list might get messed up. If I don't display that contents, how can I tell that it got messed up, right? So I need something to help me there. So I'm going to create something called a display list. I won't need any arguments because it's a global that we're going to be dealing with. Okay. So I want to basically go and loop along my list. I'm going to need an iterator variable, right? So I'm going to basically need a way to basically walk along the linked list and see which elements are there. So I'm going to start by creating an iterator list. This is pretty boilerplate. So iter head list. Okay, so that's going to be my pointer that walks along the list. And then, well, that isn't null. Then I'll do some of my important things. So iter not equal null might mean there is a list. Let's maybe print it out. So printf of node data equal, and then we'll just find that number inside of it, right? So that'll be an iter, something like that. All right, that'll loop over. That'll give me every single thing in there. Well, need a few more lines here. First of all, I need to make sure I move my iter forward so that I can actually view the next entry. I also think I want to display the number of elements in there, and this will be more useful or apparent later on. But we'll go ahead and put it in. So we'll go count, and we'll just go count equals 0, right? And then every time this loops, we'll just increment count a little bit. And then at the end, I guess we got to display it as well. So something like this. Printf node count. And we'll just display that count variable. All right, that's hopefully not too complicated. I think it is, at least because we're not doing threading yet. So we'll go ahead and do this. Okay, so let me go ahead and run this, and hopefully what we get back is the contents of the list. And it is, except that I probably need to put in a few new lines over here, right? So basically what we have here, right, is a strictly serial program that adds 10 numbers to the list, right? So nothing too surprising just yet. Okay, so this is going to be our starting place. So everything is fine right now because we're adding them one at a time and nothing can possibly go wrong. So let's suppose, though, we want to do things, I don't know, a less good way. Well, less good way, maybe. It'll be a way where, though, it's more efficient. So what I'd like to do, instead of basically having a loop here that adds these one by one, let's introduce parallelism by having a loop that creates new threads, and each of these threads then adds a node itself. Okay, so we're going to introduce parallelism, right? That's our second step, right? Our third step is going to be to add mutaces, but the second step is basically to add threading, right? So let's do that. Right now, right, it looks like it's working okay, but it's really not that interesting. So let's add a runner function. So I'll do something like this. I'm going to do void star runner, and I think I'll call it create arg node. So I'm just going to basically have this runner that I give it like the one parameter, and that one parameter is the number that I want to store in the node that I'm adding to the list. All right, something like that. That'll be my plan. So then basically, right, you can imagine I'll have in the loop over here where every single time I run, I do a pthread create and I pass it to this, and then the argument that I pass is going to be that I value. Then I can basically know that it's going to give each thread this particular number to add to the list as a different node. So we'll start with this. Let's see. Let's maybe, okay, so we have the runner there. Let's maybe start working on the runner a little bit. I'm going to do data int, or int data. Let's just kind of cast over the argument, right? So we know that we need this, right? So I want to basically call add front, right? But I want to get the data to be in the right format. So I'll do that. And then I'm going to go and I'm basically just going to add the data to the front, right? So basically, right, each one of these threads will go and add a particular number to this list. And I can see it's not happy with me there. Oh, this should be add front. That's right. That should be add front there. Oh yeah, and I'm also missing the pthread library. So let me go ahead up there and add that. So I need pthread, pthread h, there we go. And you know what, actually I also need stdlib because we're doing a malloc over here. You saw it was red. There we go, we should be good there. Okay, so this is kind of the start of our function here. And I think, well, okay, so this is enough to work as is, but it won't be as interesting as we would hope. So let's keep on going forward. Okay, so I have my code here. I want to basically switch this up so that now I'm going to be doing a pthread create. So pthread create, that's going to take a few arguments, right? Let's see. Let me do the thing where basically I create an array of TIDs. So I'm going to do thread TIDs, and let's add a constant over here really quick. So let's call this num threads. Define num threads. So I want this thing to be able to scale up very easily, so we'll do something like this. And we'll say, I don't know, maybe there's 10,000 threads. That seems like enough that it'll be interesting. So we'll do 10,000 threads. Okay, so we'll do something like this. And then over here, we can basically say, this is num threads, right? Create me that many TIDs. And then this loop right now, right, will basically go up until that endpoint, right? Let's see, what does it want? Num threads. Why does it not like my num threads? Oh, num threads 10,000, not equal 10,000. There we go. Okay, something like this. And then, right, we can fill out the arguments. First argument is going to be which TID we're looking at, right? So we're looking at the ith one, right? And we'll pass the pointer to that thing. Attributes we don't really care about. We just want it to run this thing and see what happens. We'll pass it the new thing we created, and then we'll basically send over the data for what node we want to add, right? So something like this. Now, of course, we need to do a join as well, because realistically, we don't know that they're going to be finished by this time, so we want to make sure that everything is okay. So we'll basically just pass over here again that TID index that will make sure that we are joining everything they recreated. So if we run this, I think it'll actually be okay. I was wrong. Undefined reference. Oh, I need to add the libraries for pthread. So we did the include file, but I also need to update the CMake. So let me grab this. This is our little keywords over here. Let's copy this over, get this over here, and give this a go. Let's try running this again. There we go. All right. So this is looking okay. And actually, one thing that I kind of appreciate here is I noticed they're not all in order. I was a little bit worried that they were going to be all in order. But now, right, you can actually see that they're completing at different times, right? It's not like they're going serially, right? You can see there is some parallelism here happening. So that looks pretty good to me. Yeah, they're not perfectly in order, which is well, just for us to serve the proof that we're doing what we intend to do. Okay. So we have that there. And one thing here that I'll just kind of note really quick, is that all of these are basically being added, right? And that's, well, it's a poor demonstration of mutexes right now until we get a missing one. Okay, so last time it added them all, but you notice here it says 9,997. Basically what that's telling me is that 3 nodes somehow went missing somewhere. I don't know what happened to them, right? And I could maybe try to go through this list and figure out which ones went missing. But like the point is, they're not there anymore, right? This is a problem. This is a problem. And so it'll depend, right? Sometimes I'll run it and it'll be fine. Sometimes I'll run it and one will override the other, right? Which goes to our picture, right? There's a chance where one overrides another. And so you're seeing that there were at least 3 threads that overrode one another, right? Now, one quick note here is that this really happens because I did 10,000 threads. Without the 10,000 threads here, I may not create enough threads that they will run into one another, right? If I only create like 2 threads, probably like the chances they'll collide is really low, right? The more threads I have, the higher chance that they'll collide, right? So I have to have this like at 10,000. Okay, so right now, right, we basically have our threads. They seem to be doing okay, right? I mean, they're running sometimes, right? But then we have issues like this, okay? So we have this idea, right, that they're fighting over who gets to assign into that list, right? They're all trying to do their own thing and they're failing at it. So how can we fix that? The answer is basically to add a mutex into our code. So a mutex, right, basically will guard a resource so that only one process / thread, well, I guess thread is the more accurate one, only one thread will use it at a time. So let's see how we do that. So we're using pthreads. So what I'm going to do is I'm going to go over to pthread, the library. I'm going to create a new variable. It's going to be called this, mutex underscore t. This is a variable that's used to represent a lock, right? I'm going to call this list lock. And so the idea is that, not over there, over here, basically this head variable here, right? There'll also be something over here that is a lock, right? And every thread will need to access it, right? And so this is either true or false, right? One of the two. And so basically, unless you have that, well, then you're not allowed to change this list here. So we have list lock. What should we do now? Well, inside of pthreads, we basically have to do an init on it before we can actually go and use it for anything. It's kind of a little bit like having to do the pthread create. So we'll have to do an initialization. So that'll be our first step. So I have my mutex over there. And what I'm going to go do is I'm going to do a mutex init on it. And we won't use any attributes. That'll be fine for us there. Okay, so now the mutex is set up. Other thing I'll do here really quick is also just going to destroy it. Overall, what you're going to see is that the syntax and stuff for mutex isn't that complicated. The logic can be tricky, but the syntax itself is pretty straightforward. So basically, we created a global variable. Now we have basically my mutex init and my mutex destroy. So we have those there. And let's see. That should already be good to go over there. We're not going to change inside of the thread, right? Rather, we're going to change add front. So add front is a function manipulates the linked list. That's the thing changing this global value. That's the thing that needs to be updated, right? That's the thing that needs to be made thread safe, right? So right now, this is not thread safe. All right. This one technically isn't thread safe either, but it doesn't really matter because we're not going to use it when we're having a thread active, right? We use it afterwards. So, okay. So let's basically fix this thing. So what I want to do is figure out the critical section in my add front. So my add front is the piece of code that manipulates the resource that things are competing for. So I want to mark a certain region as this can only happen at one time. And I want that region, right? That critical section that's mutually exclusive to be as small as possible. And so I have to figure out how can I do that, right? Which line should I include in my region? Now in this case, right, I start with the malloc. The malloc isn't really something I want in the region because everybody can allocate their own memory separately, right? That's not overriding one another. Same thing with the assignment to data. Data, right, is this thing that I have just in each thread. It's not a global, right? Now, where I do get into trouble is over here. So when I use list head and list head again, those are both a global variable. Something's going to be changing there, right? Something might be changing there, right? Because somebody else has access to it as well. It's a global variable. So this is my region that I'll want to guard. And so I'm going to write something like this. I'll go my pthread mutex, but then what I'll do, right, is I'll try to lock it first, right? And this is a blocking command, so it's not going to let me go forward until line 22 until line 21 acquires the lock. Right, so only one person can do it at a time, or only one thread can do it at a time. So something like this. We'll do a lock there, and then I'll go over here, pthread mutex unlock. And we'll basically give it the same thing again, list lock. And there you go. This is code that is now in a critical section. The particular thread has to have access to this mutex before they can get into the section and run these two lines of code. I just did something really stylistic. I indented my code. Some people do this, some people don't. It's up to you. I sometimes indent my code inside of a mutex so that I know this is the block of code that is inside of the mutex. All right, and so now this should be thread safe. So let's go ahead and try running this and see what we get. 10,000. So let's run this a few times, right? Last time, right, we basically said that we were running it, right, and we had to run it a couple times and then it gave us an error. So now the bold claim is that if I run this a whole bunch of times, we won't ever see an issue. And we're not seeing an issue. So hopefully that means it's good. I mean, I know logically it is good, but I know sometimes it's hard to convince yourself. And so the idea is that basically, right, you don't end up with this issue anymore, right? So in this issue, right, we had a problem because I have to go way back. Way back. Will my undo last as long as it will? All right. I have to go way back, right? So here, right, this is where I had the issue. Because I can assign the next to the head in both of them at the same time, and then one moves forward and replays it. But now we're saying is that basically these things happen atomically. So linking to the next, as well as updating head to B, this node happens in one go, right? So this is sort of like, you know, thread one acts and this happens, right? So A, right, this is basically, you know, A is basically that first critical section that runs, right? And once it's done, right, so A runs over here. Let's make that an A. Then T2 goes, right? And it does maybe actions B, right? And so B is basically, I will attach this to this, and then I'll update this to be this. Okay. So these happen basically in order, right? So these two happen together, these two happen together. Therefore, we're going to correctly build our list, and we're going to have a list at the end of the day. It looks like 2, 1, 3. Contests are all there. Order is different. That's another story, but contests are all there. So in that case, we don't have any issues with threading anymore. All right. So hopefully that makes sense. That was an example of using a mutex in C to manage multiple threads, adding to a linked list, and making sure nothing got lost. Thanks for watching. I'll see you guys in another video.